This is the video on 2-8, proportions with similar figures. Let's continue with our vocab where we left off. We left off at similar figures. Similar figures are figures that have the same shape but not necessarily the same size. So their side lengths are proportional with each other and their angles are the same, so they're the exact same shape but they're different sizes. And this squiggly line here is what communicates that they are similar figures. A scale drawing is a drawing that shows a real object with accurate proportions reduced or enlarged by a certain amount. So for example, a map is the best example that I can think of that is a scale drawing. Another example of a scale drawing would be when you're building a house and the builder gives you a drawing of what your house is going to look like before he actually starts building. Those are scale drawings. And then you have a scale. And a scale is the amount the scale drawing was reduced or enlarged by. So for example, on a map, they may say 1 inch on the map represents 100 miles in real life. On your house plans that the builder gives you, he may say 1 inch on the plans represents 10 feet in real life. And so that's a scale. But you can also have a scale for a scale model. A scale model is a 3D representation of a physical object where all proportions remain the same. So for example, a model airplane. And how that works on, let's say, a model airplane is, if, for example, the wheel on the model airplane is twice as big as the window, that means in real life, the wheel of the airplane is twice as big as the window. Everything is in proportion to each other. Okay, so let's continue with our examples. We're going to go to example number 3 here. Solve for x. This squiggly line tells me that these triangles are in proportion to each other. And so there's a couple different ways you can set this up. I think the easiest way to do this is to say x over 15 equals 5 over 3. X over 15 equals 5 over 3. So notice what I'm doing here. Let's call this triangle number 1, and let's call this triangle number 2. Here are the side lengths in triangle number 1, and here are the side lengths in triangle number 2. I'm keeping them together. And then this, let's say we call this side A, we call this side A, we call this side B, we call this side B. So then here, this is the same side, which here we call this side A. And 15 and 3, these are the same side. And we call this side B. So notice how I set it up. Same triangle, same triangle, same side, same side. And guess what? You can actually set it up the other way. You can say x over 5 is going to equal 15 over 3. What did I do? I just switched it. I said same side, same triangle, same triangle. But I promise you, you could probably already see it. Once I use the cross product property, my answer is going to be the exact same. Does not matter, however you want to set it up. So let me show you how you solve using the cross product property. We're going to say 3x equals 15 times 5, which is 75. So then x equals 25. Okay, let me go to the next example. I like to set it up like this. Same triangle, same triangle. I think that's easier. This fraction is one triangle, this fraction is the other triangle, and I need to make sure horizontally this is the same side and this is the same side. I think that's easier, but it doesn't matter. You'll get the same answer. Okay, so let's figure out this. I want to find side length DE. So that's over here. So I'm going to say 10 over 16 10 over 16 is the same as saying x over 12. 10 over 16 is equal to x over 12. Now I just use my cross product property and I get 120 equals 16x, and so 120 divided by 16 is going to be 7.5. So x is 7.5 here. So this is 7.5. Okay, so now do the on your own, and let's see how you do. Okay, so now I want to find AC right here. Let's call it Y. I want to find side length AC. Again, there's a couple different ways you can do this, but I'm going to say 16 over Y equals 12 over 18. 16 over Y equals 12 over 18. Now again, there's a couple different ways to set this up, and if you set it up a different way, but you don't know what you did wrong, if you got it incorrect, email me and let me help you figure that out. And so now I'm just going to use the cross product property, and I'm going to say 12y equals 18 times 6. No, 18 times 16, which is 288. And so then y is going to equal 288 divided by 12, which is 24. Again, same triangle, same triangle. We can call this triangle number 1, and we can call this triangle number 2. This is triangle number 1, and this is triangle number 2. Same thing here. This was triangle number 1, and this is triangle number 2. And then horizontally, same side, same side. Okay, on the next one, I said, draw a picture. A man who is 6 feet tall is standing next to a flagpole. So I got a man, and I got a flagpole. And you were told in 3rd grade, when you read a word problem, draw a picture. It's no different. Just because you're in high school, no different. Draw a picture. A man who's 6 feet tall is standing next to a flagpole. So he's 6 feet tall. The shadow of the man is 3 feet. 3.5 feet, excuse me. And the shadow of the flagpole is 17.5 feet. So we would, I'm a terrible artist, so we would say my drawing is not to scale here. I'm a terrible artist, but in any case, now we need to figure out the height of the flagpole. Well, these are going to be in proportion to one another. Why? It's the same sun shining down on them, same time of day. They're in proportion to one another. So what does that mean? 6 over 3.5 equals x over 17.5. 6 over 3.5 equals x over 17.5. And so think about what I'm saying here. This right here is the man, and this right here is the flagpole. This fraction is everything for the man, and this fraction is everything for the flagpole. Going this way, this is my actual height, and going this way, this is my shadow. But do you see how it's the same? And now I solve. Using the cross product property, I'm going to say 3.5 times x is going to equal 17.5 times 6, which is 105. And so then x is going to equal 105 divided by 3.5, which is 30. So it's 30 feet. Okay, last example. If 1 inch on a map is 110 miles, how many miles is 1.25 inches? Again, more than one way you can set this up, but what I'm going to say is inches over miles equals, let's set it like that. So 1 inch on a map is 110 miles. So then therefore, inches over miles, 1.25 inches is how many miles? Inches over miles equals inches over miles. Inches over miles equals inches over miles. Cross product property, 1 equals 110 times 1.25, which is 137.5 miles. Sorry. Okay, and finally go ahead and do this last example. Okay, inches over miles equals inches over miles. 1 inch is 110 miles, so then 0.6 inches is how many miles? You may be able to solve this in your head without setting it up as a proportion, but since this is a lesson in understanding proportions, please solve it by setting it up as a proportion. Because one day it may be something that you can't figure out in your head. You need to know how to set up the proportion. Miles. Okay, so go ahead and hit stop, do your homework, and let me know if you have any questions.